Hello, welcome to Advanced Algebra 2. Here we're starting what is apparently the 11th learning target, but don't worry about that too much. It's the next chapter in your book after the ones we've done so far-ish. We're going to talk about logarithms eventually. Logarithm, that's a funny word. You likely don't have any idea what it means yet. Don't worry about that. For the future you, logarithm means backwards exponent, but that sounds frightening already. Don't let it go. For now, we're going to do forwards exponents, and you're really best off if you at least scan pages 241 to 245 in your textbook before you look at these examples. There's some good couple examples, but also just some good reasons about why the notation and the rules are what they are now. So it is worth your time and your scanning. At a minimum, I really need to encourage you to look at those 4 blue boxes on those pages. Those are where the actual rules themselves are kind of highlighted. We're going to be using those formulas moving forward all the time. So saying that, let's move forward. Hey, here we go. We're going to use the properties of exponents and a calculator to approximate the value of the 10th root of 1,020,301. So, first order of business, just want to remind you, and when I say remind, I mean say for the first time, that the 10th root of a number, in this case 1,020,301, is that number to the reciprocal power. So the 10th root is the blich to the 1/10th power. That's key brand new information. Now, if you have a graphing calculator, you can just do these roots just straightforward, and some scientific calculators will do them too, but you got to get used to how that works with the powers anyway. If you're doing it old school on those fun little calculators, you'd enter it like this with a little power button and then the 1/10th. Do make sure that you add that 1/10th in parentheses. If you don't, it'll do it to the first, which isn't interesting, and then divide the answer by 10. And that just moves a decimal point. That doesn't actually do anything for you. Hey, so if you do it, and I do recommend you do it, you'll get about 3.9891-ish. It's worth doing, making sure you've got calculator skills, and, if it doesn't work once, try it again. If it doesn't work a second time, I don't know, throw your calculator across the room. No, don't really throw your calculator across the room, but talk to me about it and I'll help you out. Okay, fast, hopefully straightforward. Second example should also be straightforward. We're going to use the properties of exponents to simplify the following expression. And then there's the thing about no variables in the denominator and whatever. Okay, so first order of business, I'm going to rewrite it with the constants in front, the coefficients, the numbers in front. So we've got 7 times 8, and then x to the negative 3 and x to the 9th later. So 7 times 8, it's 56. And then since we're talking about business with powers of the x's, I'm going to add those powers, so negative 3 plus 9. So 56 times x to the 6th. Boom, there you have it. Not so long, really. Here we got example 3. Same basic idea, but now it's longer. So I'm going to work to make this look as long as possible, just to show you each of the little pieces. It is not expected that you always, do each little piece, but, you'll find your own shortcuts as we work our way through. So, the first order of business, that 5 is to the 4th, and the a to the 3rd is also to the 4th, and the b to the negative 2nd is also the 4th. And then over on the right half, the 5 is to the negative 2nd, the a to the negative 4th is to the negative 2nd, and the b to the negative 5th is also to the negative 2nd. Good times. Now, 5 to the 4th, that's 625. And then a to the 3rd to the 4th is a to the 3 times 4. B to the negative 2nd to the 4th is b to the negative 2 times 4. 5 to the negative 2nd is 1 over 25, because it's 1 over 5 squared. And then same thing with the other a's and b's. If you've got a power of a power, the exponents multiply. So, trying to make this look longer here. 625, we got a to the 12th. We got b to the negative 8th, 1/25. A to the 8th, and b to the 10th. Now I'm going to reorder it just to put all the numbers in front and the a's together and the b's together. So we got 625 times 1/25. We got a to the 12th. We got a to the 8th. And we're rocking and rolling. We got b to the negative 8th. We got b to the 10th. Boom, 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 boom. Okay, 625 times 1/25. look, I can make this look like it'll take forever. But, you know, it's worth noticing, oh yeah, that's like the 625 is up top in the numerator with 25 down below. Okay, for the a's, the exponents add. For the b's, the exponents add. This shouldn't be brand new or exciting. Seriously, if the part where the exponents add is exciting, we should talk. I will help make it less exciting for you. 625 over 25 is, well, it's 25. We got a to the 20th. We got b to the 2nd. Boom, chicka boom, we're done. Boy, I made that look like it took so long time. Oh, well. Okay, so, moving on. Oh, look at this. So, man, this is exciting because check this out. You got 3 to the 4th, and you got all its a's and b's and, I guess, d's up top. You got 43 to the 0th power. Whew. That's not a lot of 43s. Okay, so up top, 3 to the 4th is 81. I'm just going to rewrite the a's and b's and d's. On the bottom, 43 to the 0 is 1, because remember, anything to the 0 is 1, well, except for 0 to the 0. But 0 to the 0 causes a black hole, in which no matter nor even light can escape, and that's bad. Don't even think about it. Okay, so I was just making up stuff while we wrote a and b and c in the denominator. Okay, so now we're talking about 81 over 1. That's 81, because, you know, dividing by 1. For the a's, go ahead and subtract the exponents. For the b's, we can also subtract the exponents. Now, the c business is a little tricky because there's no one to subtract. Go back to that later. And d to the negative 4th, and there's nothing to subtract it from. Okay, so now we got 81. Now, this is a to the negative 3rd. You have b to the 8th. Now, since it was 1 over c to the 6th, it's c to the negative 6th. And then the d never really bothered to change anything. Yeah. Okay. Now, last one. This one's faster than the example 4. Just a quick reminder here. If it's the 5th root, that means the business is to the 1/5 power. You want to be careful. Not the 5th power, the 1/5 fraction style power. And so then, you know, it's each piece is to the 1/5 power. And that means you multiply them. So it's 30 times 1/5. And for the k's, it's 32 times 1/5. And then 30 times a 5th is 6. 32 fifths. I mean, you could write 6.4 if you want. But, you know, that's it. We're done. The rules apply. There's good practice here. There's actually better practice coming up on this assignment. It might be worth your time to get started on a few of them just to kind of get your wrist moving and make you feel a little confident in it coming into class. No shame if you don't, though. We'll have plenty of time to work through it and get your questions answered in class anyway. Thank you for watching, and please let me know if you have any questions.